Rain stops play again. Despite a lower than average rainfall, we only seem to notice the weather when it stops us to land, like a game of cricket.
I'm not going over there.
We can all describe different types of weather and how these affect our daily lives. But what causes weather? Why is the greenhouse effect important? Should we be worrying about a possible climate change? Let's look at some of these questions and try to see how they might affect us all in the years to come. Let's start by taking a look at the Earth's atmosphere. This thin but important blanket which surrounds the Earth preserves life on our planet. Although we can't see them, the atmosphere is divided into a series of layers, rather like the skin of an onion. The lowest layer is known as the troposphere and extends from ground level to a height of about 15 kilometers. This layer contains most of the water vapor and is the layer responsible for most of the weather systems. From 15 to 50 kilometers is the stratosphere, the layer in which supersonic planes like Concorde fly and where our highest flying balloons can reach. The stratosphere also contains most of the ozone in the atmosphere. Ozone, a form of oxygen, absorbs harmful ultraviolet radiation from the sun. By doing this, it prevents most of this radiation from reaching the Earth's surface, where it could damage vegetation and cause skin cancer. There's evidence that chemicals known as CFCs, which have been used in aerosols and refrigerators, have caused a reduction in the ozone concentration in the stratosphere. New chemicals which don't cause a loss of ozone are gradually replacing CFCs. But it'll be some years before we know how serious the damage has been. Above 50 kilometers, the atmosphere continues to thin out. First as the mesosphere, and then outwards from 80 kilometers as the thermosphere. This fragile envelope of gas is all that sustains and protects life on this planet. But we shouldn't assume that the atmosphere is insubstantial. For example, it provides enough friction for particles of dust from outer space to burn up as they pass through it. We sometimes see these as meteors in the night sky, shooting stars. The atmosphere exerts a pressure on the Earth and on all of us. You might be surprised to know that the atmosphere exerts a pressure on your hands equivalent to 2 sacks of potatoes. Fortunately, air pressure acts in all directions, so it supports your hands from underneath as well. If it didn't, you'd never manage to put your hand up in class. The atmosphere can also exert tremendous forces through the weather systems which exist in the troposphere. Hurricane force winds can destroy the strongest of trees and demolish buildings. In some parts of the world, hurricanes occur in the same season every year. They don't happen in Britain, but violent storms like that of October 1987 can still cause serious damage. These pictures were taken the day after that stormy night in 1987. But you can see that the wind was still blowing far more strongly than we're used to. Enough to blow buses and lorries off the road, destroy woods and wreck buildings. If the atmosphere is the place where weather systems develop, what causes the different types of weather we experience, from calm days with blue skies to raging seas and gale-force winds? Well, it's the sun that ultimately provides the energy to drive our weather, whatever form it takes. The Earth receives energy from the Sun at an almost constant rate. But several factors cause that energy to be distributed around the world in very different ways. For a start, different points of the Earth's curved surface receive different amounts of energy. The tropics directly facing the Sun, and with a minimum of atmosphere to penetrate, get the most, the poles the least. The tilt of the Earth's axis, as it orbits the Sun each year, means that the same parts of the Earth's surface receive different amounts of energy from the Sun, depending on the season. This in turn causes seasonal changes in the weather. Most of the Earth's surface experiences temperatures in the range of plus 35 degrees Celsius to minus 5 degrees Celsius. But extremes of minus 88 degrees Celsius and plus 58 degrees Celsius have been recorded. It's a sobering thought that if the energy the Earth receives from the Sun was reduced by as little as 10%, then life could not survive on our planet. Of all the energy reaching across the 150 million kilometers of space from the Sun to the Earth, only about half reaches the surface in the end. Of the rest, some is reflected off the surface and back into space. Some is reflected off the clouds into space or into the atmosphere, or it's absorbed by the clouds. And the same thing happens as a result of the dust particles suspended in the atmosphere. It's all the energy knocking around in the atmosphere that causes it to be in constant motion. The winds which contribute to this constant motion are caused by differences in pressure in the atmosphere. Air above the equator is heated and rises, to be replaced by cooler air in the tropics. As the heated air rises, it cools and clouds form which release precipitation as rain. This form of circulation is called a Hadley cell. Other differences in pressure are caused by the different heating effects of solar energy on land compared with the oceans. Air above a landmass heats up more rapidly than that above the ocean. This warm air rises, reducing the air pressure over the land. Cooler air flows from areas of high pressure to replace it. Understanding airflow, and hence the cause of the winds, is made more complex because the Earth is rotating on its axis. We'd expect air to flow straight from high pressure to low pressure areas. In fact, the effect of the Earth's rotation is to make air generally flow parallel to the isobars, the lines linking points of equal pressure. Energy from the Sun is also responsible for cloud formation. It causes water to evaporate from the surface of oceans, lakes and rivers. The warm, moist air is replaced by cooler air to maintain the cycle. As the moist air expands and rises due to convection, it's cooled. The water in the air begins to condense as tiny droplets to form clouds. The clouds are carried along in the atmosphere, but as they pass over high ground, are forced to rise. This causes further cooling, and the air is no longer able to hold as much water, and so it falls as rain, snow or hail. This process of heating and evaporation, followed by cooling and precipitation, is known as the water cycle, and it's had a big impact on the Earth.
Good evening. Last night there was a touch of frost over many parts of the region, and although for most western areas it had gone by the morning...
Predicting the weather with any degree of accuracy is a highly technical and skilled process. We may come often wrong. Yet in order to be able to predict the weather even 12 hours ahead, meteorologists may need data from 3,000 kilometres away.
There's been gradually edging across the region, some heavier bursts around the middle of the day, but most of it is light rain now. And the back edge, the real clearance, has made some progress in the afternoon.
The information the weather forecasters need may come in the form of radar images from weather satellites, or data from aircraft, balloons, ships, automatic weather stations and observers around the globe. The satellite information has added to the more traditional methods, but there's still a place alongside the dishes for direct human observation of the weather. Just going outside and having a look at what the weather's doing where you are and reporting back to the weather stations. The Meteorological Office in Britain makes regular flights with its special weather plane that can measure weather factors ranging in size from drops of rain to 200-kilometre long weather fronts. With all this data arriving from so many sources, powerful computers are needed to process it all and apply it to a computer model of the atmosphere. Only then do human forecasters take over, evaluating the predicted changes and using their experience to interpret these on a local basis. Even then, to provide an accurate forecast for a local area presents enormous difficulties.
Yeah, good afternoon. Farnborough Met here. Frost warning for you.
Where skies clear, it could well become quite frosty. I think in terms more of a ground frost than an air frost, but that's enough to make some icy patches on the road where they're still damp, and the breeze just keeping temperatures above freezing in the north of the region. Tomorrow, starting bright, the odd icy patch on the roads as well.
However difficult the task, we all still watch or listen to weather forecasts if we plan a day out. But what do the weather charts mean? We've all heard forecasters talking about depressions, anticyclones, weather fronts. But what are they? And how do they affect the weather? Depressions, or low-pressure areas, and anticyclones, or high-pressure areas, are produced by vertical movement of air in the atmosphere. Warm air rising by convection reduces the air pressure on the surface of the Earth, forming a depression, or low-pressure area. As this warm air rises, it's cooled and clouds form which may produce rain. The rising warm air is replaced by cooler air, and this sinking air increases the surface air pressure, forming an anticyclone or high pressure area. As the air sinks, it's warmed, inhibiting cloud formation and producing clear skies. In the case of both depressions and anticyclones, the rotation of the Earth, in turn, produces a rotation of the air in the area. We shouldn't underestimate the part which weather has played in shaping the land masses of the planet. The effects of water in its different forms on the landscape can be quite dramatic. Flowing water can, over a period of time, erode rocks to produce dramatic river valleys like the Grand. Water in the form of ice can gouge out U-shaped valleys along as the glaciers grind their way across the landscape, creating the typical alpine terrain of eroded valleys and transported boulders. In the last ice age, this happened to valleys in Scotland and the north of England. The action of waves can wash away areas of coastline, carrying material away from one place and depositing it as a spit on another part of the coast. Even the simple conversion of ice can split rocks or crack roads as the spans in wintertime. Wind can carry particles of dust and sand. This can also cause changes in the landscape. Sand dunes can be gradually moved several kilometres over a period of time. Wind-blown sand can also erode softer rock, often carving dramatic shapes. Even buildings and statues are not immune to this. Among them, the famous Sphinx of Egypt, eroded by sand for 4,500 years. The climate everywhere on Earth supports some form of life. But even on our small planet, there are considerable variations. This is the South American rainforest. The effects of the sun's energy and the tilt of the Earth's axis produce different types of climate in different parts of the world. The climate of a particular location is determined by such factors as wind, temperature, and precipitation. These in turn are directly related to the geography, both latitude and height above sea level of the location. For example, rays pass through more atmosphere to reach the poles, so the poles receive less energy than the tropics. The regions around latitudes of 30 degrees receive dry sinking of convection heating in the equatorial region. These areas are the location of the Earth's major deserts. The different climate zones of the Earth have produced a range of different plant and animal types on our planet. They've also influenced human societies and lifestyles. The lush vegetation and plentiful life of the tropical regions contrast markedly with the harsh conditions for life in the polar regions. We might think that these climate zones are fixed, but we know that the position of the continents has changed over the years. Places that were once on the equator are now in cooler latitudes. Apart from this, the Earth's motion isn't perfectly regular. Minor variations in its orbit around the Sun almost certainly cause the ice ages. During the most recent of these, the ice sheet covered much of northern Europe. We can tell what the climate in Britain was like from the fossils of this period. Cold climate creatures like woolly rhinos, reindeer, mammoths. Before that, there was a much warmer climate with lions, elephants and hippos. Although we've had some recent warm and dry years, another ice age is expected. It's due in the next 10,000 years. Unless human activities have changed the climate of the planet before then, with a greenhouse effect produced by all the pollution we're sending into the Earth's atmosphere,